Hello guys, welcome back to MathZone African Motives. This is our mathematics N6 working on integration, and this is one of the most important part of our syllabus in our revisions. You need to understand conditions where integration by parts is applied, which, like I said, is very, very important in your syllabus. In part of integration, as a whole, we know that it carries 18 marks. All right. So integration, it carries 18 marks in our syllabus. So the integration by parts is a continuation from our mathematics N5. So I want you guys to make sure that you also watch the introduction for mathematics N5 if you are new to this YouTube channel of mine. But if you have watched the other videos before, then it's fine. It's a continuation. All right. So remember, in our mathematics N5, I introduced you guys to integration by parts and say that if you are given a condition of a product, all right, it's actually a product of two terms. It can be an algebraic term and a trigonometric term, all right, like this. It's a product of two terms and you're asked to integrate. On that condition, you are supposed to apply integration by parts. Yes, we saw that there was an introduction of by parts that we had, and it was a lot of things that we had to consider, which is exactly the same with this part. Okay, so I told you guys that the integral of f of x g prime x, which is indicating the derivative, all right, with respect to x is equal to the product of f of x and gx minus the integral of f prime x times gx with respect to x. So remember, our integration dx just indicate with respect to x, with respect to. So what are we saying here? This is a function of x. That is a function that can be differentiated. Remember, we said this can be differentiated, all right, to give us f prime. It must be differentiated. Then the g prime dx that is remaining is supposed to be integrated to give us gx. So this is supposed to be integrated. All right, this is supposed to be differentiated to give us f prime. The g prime, the g prime x dx is supposed to be integrated to give us gx. This is what we understand. All right, no problem. Let us get this into consideration and see what exactly are we talking about here on these two functions. Okay. If a product of two terms is being applied, let's say we've got number one, the integral of x squared e to the exponent of 3x with respect to x. So we've got an algebraic and we've got an exponential. There are two terms there, an algebraic and an exponential. In case of having an algebraic and exponential, take note, this can be differentiated. We know that. Also, this can be differentiated. We know that. This can be integrated. We know that. And also, this can be integrated. So you'll be wondering now in exam, which part is best for me to choose? It is always of best choice whenever there is an algebraic expression or an algebraic term to be taken as your f of x. So it is best whenever you are working with an algebraic to make it your f of x. Okay? It is always best. Not that. It is always best. So meaning to say that I'm going to let I have the formula here. So I'm going to let, because I have to say this is my f of x. So I'm going to let my f of x to be equal to the algebraic term, which is x squared. And what is remaining if I remove the f of x? What is remaining is the g prime dx. This is the part that is remaining. And this is the part that is remaining on this side. So you have to be very, very careful. So this part is representing this part that is remaining. So it means here our g prime and our g prime x dx is equal to what? This remaining part of the exponential, which is e to the exponent of 3x dx. So that's it. So what is it that we need? That is the question. All right, that you have to ask yourself that. What do I need? All right, I said from f of x, we need its derivative. From g prime x, we need its integral. That's it. So here we are going to need the first derivative of f of x. So what is the derivative here? The derivative of f of x, guys, remember your derivative. So this is going to be 2x. Drop the exponent, then subtract 1. So that is going to be 2x from our mathematics N3, all right? And here, how do I find gx? We said we integrate this, okay, from our mathematics N5. Said we're going to integrate both sides so that we remain with gx. So this will give us gx, which is the integral of e to the exponent of 3x. So there, we are still going back to our revision and so forth. Yes, we can use our formula sheet, which is fine. I'm just going to go through the formula sheet, but you're supposed to know your integrals, all right? But for the sake of, your integrals, you're supposed to know them for the sake of revision. If we are given e to the exponent of ax plus b, let us just say it's a function of e to the exponent of f of x. It follows that in actual sense, let me have it here because here they didn't write it for us. It's not like e cannot be integrated. E can be integrated. I don't know how they didn't list this one. So the integral here, because we're dealing with the integral on this part. So the integral of e to the exponent of f of x, it follows that it is e to the exponent of f of x over the first derivative of f of x plus the constant of integration. So whenever I see this e, like on this part, all right, let us try to go back on our question. All right, just gonna try here. Let us just try to go back to our question. So I told you, I showed you there, how do you work out e? Only that here it's not given. So you're just supposed to be careful on e, but you're supposed to know this. All right, when it is e, the integral of e, so let's just save it this way. The integral of e to the exponent of f of x, this is the integral of e to the exponent of f of x with respect to x, is equal to e to the exponent of f of x over the first derivative with respect to x. That is how we can integrate e, all right? So meaning to say that on this a to the exponent of 3x, this is our f of x, this one. So our f of x. And what we need from there is its derivative because it's going to remain as it is, e to the exponent of 3x over the first derivative of f of x, which is the first derivative of 3x. What is the first derivative of that? It is 3, right? Remember, guys, our basic derivatives, okay? So this will give us a 3. So this is what we need. With this information, we're going to take it down back here. So I'm just gonna take it down to the formula, all right? So take note of our formula here. All right, for that. So the formula states that this is going to give us, okay, this whole integral that we have is going to be equal to, let me just write it down, the integral of e of x squared e to the exponent of 3x with respect to x is equal to f of x by gx. So it's the product of our f of x, which we said is x squared. So that is x squared times gx. And this is our gx, which is e to the exponent of 3x over 3. All right, let's move on. Minus the integral of the first derivative of f of x, which is the first derivative here, is 2x. So that will be 2x times gx which is e to the exponent of 3x over 3, right, with respect to x. So this is it. We're going to integrate this whole part with respect to x. So I want you to see something very, very special that is happening here, all right, of which this I can just combine it to be like a single term, everything over 3, or I can write it as 1 over 3x squared. It's up to you the way that you want to write it, guys, all right? So this I'm just going to write it as x squared e to the exponent of 3x, everything over 3, because this is same as 1, so it's going to multiply 1 and 1, these numerators together, minus, I can just take out these 2 over 3, so technically this is 2 over 3. 2 is in the numerator, 3 is in the denominator, so I can take the constant out of the integral, so it's 2 over 3. What do I remain with if I take these 2 over 3 out of the integral? I'm going to remain with x times e to the exponent of 3x with respect to x. Okay. This is what was going to happen. Like in actual sense, this is what was going to happen. You're supposed to integrate this. Take note. You're supposed to integrate this. And by just looking into this, we can see that we are back again to a product, like I explained, of two terms, a product of two terms. So in order for us to integrate this, it means we have to apply by parts again. So this is what I want you to take into consideration. Whenever you work with an algebraic raised to a certain exponent and an exponential, the exponent on the x, the exponent on the algebraic, this exponent represents the number of times you are going to apply by parts method. Take note, the exponent here on x, when you're dealing with an algebraic and an exponential, the exponent on x represents the number of times you are going to apply your by parts method. So meaning to say, if there was an exponent of 3 here, we were going to apply by parts 3 times. If there was an exponent of 4 here, we're going to apply by parts 4 times. Because there is a 2, you're going to see that we are going to use by parts 2 times. So we used by parts here in the first place on this one. It was by parts here to just use this formula, this part. We applied by parts. But like I said, the moment we want to integrate this part here, what are we supposed to do? We are supposed to apply again by parts, because this can only be integrated by parts because it's a product. So we are going to integrate this, then we combine our answer at the end. All right, so this is what I'm just going to do. I'm just going to take this aside. We want to integrate this. So instead of you writing this aside here, you can write your calculations aside. All right, your calculations can be made aside. So let us just make our calculations aside. All right. So on this side, we are going to integrate. So we are going to integrate this x e to the exponent of 3x, right? So this is the integral of this with respect to x. So this is what we need, okay? This part, this is the one that we need. So let us integrate this and see. Okay, so like I said, by parts, we're gonna need f of x and g prime x, and always f of x when dealing with an exponential and algebraic. The algebraic is always your f of x. So you're going to say, let f of x be equal to x, which is the algebraic, and we're going to have the g prime x, which is the remaining part. Remember, the remaining part is g prime. All right, we already have this here, which is g prime x dx. So that will be g prime x dx, which is the remaining part. This is the part that is remaining of e to the exponent of 3x with respect to. So as you can see, it's a repetition of this part here that we already have. All right, but anyways, let us differentiate. If we differentiate x, we get a 1. All right, then we say to obtain gx from g prime x, you integrate both sides. And this is the one that we did here, and it's just going to give us gx, which is equal to e to the exponent of 3x over 3. I explained how to integrate e on this part. So just going to be careful about that integral of e. So this is it. Remember, what are we supposed to integrate is this part of x times e to the exponent of 3x. So from our formula, we said the integral of this type is going to be given by f of x by gx. This is our by parts formula, all right? F of x by gx. So we're going to multiply f of x and gx first. So f of x, which is x, times gx, we got e to the exponent of 3x over 3 minus, what are we going to subtract? We are going to subtract, in this case, f prime x, which is the derivative of f of x times gx. Where is our f prime x? F prime x is a 1. So this is going to be the integral of 1 times gx, which is e to the exponent of 3x over 3 with respect to x. All right, so that is it. We can now integrate this part. We can now simplify this, and it's going to be x e to the exponent of 3x everything over 3 minus, just like the last part, we've got 1 times 1 over 3. So you're going to we're going to remove this 1 over 3 out of the integral. So if we remove 1 over 3 out of the integral, we are going to remain with e to the exponent of 3x. So this is e to the exponent of 3x with respect to x. So take note, this time we are just left with the integral of e to the exponent of, which is a normal integral. There's nothing that we are going to do. We are not going to introduce any by parts. It's a normal integral, and we talked about this. The integral of e to the exponent of 3x gave us what? E to the exponent of 3x over what? Over 3. So meaning to say here, we are going to obtain x times e to the exponent of 3x over 3 minus 1 over 3 times e to the exponent of 3x over 3, which is the integral of this part, all right? Then we've got our cost of integration. The cost of integration, you write it at the end when you're done with the whole integral, okay? So this is going to give us x times e to the exponent of 3x over 3 minus, just multiply the numerators together. That is going to be e to the exponent of 3x over, multiply the denominators together, 3 times 3, that's a 9. So this integral here, this integral of x times e to the exponent of 3x, when simplified, it is going to give us this, which is x times e to the exponent of 3x over 3. This is what you're going to have, minus e to the exponent over 9, this one. So where did we get this integral? It was here. Remember, we were integrating this side here. We're integrating, this was our question. When we integrated at this stage, we were at this stage where we said we have to apply by parts again. So we are going to just substitute this whole integral that we had, which is the integral of x squared, whatever that we had, we are just going to substitute and see. So we had the integral of x squared e to the exponent of 3x with respect to x. This was our question. So this is what we got from the first part of our question, all right? We got x squared, that was x squared like this, e to the exponent of 3x over 3 minus 2 over 3 times the integral of this, so it's 2 over 3 times the integral of this part, and we got the answer of this integral. So you're just going to take the answer that we got of our integral. Remember, when we integrated, this is what we got here on this side here. So you're just going to write the answer that we got here as it is. So we got x times e to the exponent of 3x over 3 minus e to the exponent of 3x over 9. This is what we got, isn't it? Yeah, this is it. So this is the whole part that we got. So we substituted now this into the what? Into the integral. All right, let me just reduce a little bit here. All right. So we substituted into the integral that we had before, this one. So this is what we had here, because we are supposed to integrate this. And we integrated this, we got this part. All right. So write the answer now of the integral. So as you can see, we can now write our constant of integration because we are done. There's no integral sign that we're going to have. All right. So let us just simplify. This is going to give us, remember I said this is same as 1/3. Let me just write in the way that you guys always understand. 1/3 x squared e to the exponent of 3x. All right. So here we're going to expand, or you can just leave it like that. At this stage, you can even leave it like that, okay? Or you can expand. Minus 2/3, it multiplies, this is 1/3. So it's this times this 1/3, right? So meaning to say you're going to have negative 2/9. Negative this one times 1/3. Negative 2/3 times 1/3. That will be negative 2/9. 3 times 3, that's a 9. All right, x times e to the exponent of 3x. You do the same thing. This is same as minus 1/9. So it's minus 2/3 times minus 1/9. So if you multiply this, minus 2/3 times minus 1/9, that will be a positive, all right? So there we're going to get a positive 2/27. So that's positive 2/27. The e remains as it is, e to the exponent of 3x plus the constant of integration. So that is how we're supposed to work out this question. At this stage, you're done. There's nothing that you're going to do, cannot integrate further. So as you saw, your bypass method is very, very important. It's very, very important, as you can see. We applied the first part, we had to apply bypass application of the formula. But when we did so, we saw that at this stage, we had to apply again by parts because we had a product. So we had to apply by parts again. That is where we had to integrate this aside. So like I said, this is not part of this calculation. You do it aside, okay? You integrate, you get your answer. This answer that you obtain, you then just substitute into this integral because you are showing us that this integral gives us this answer. Then you can simplify further. If there are like terms that can be added or subtracted here, you can combine. But as you can see, we do not have any like term that we have. All right, so like I said, you need to know where to use by parts, one, and how to use by parts. So we saw that we can have a by parts when dealing with a product. All right, so it can be a product. Let me just write down conditions. I don't want to remove this formula so that we can just work out with the formula. Or let me just remove, I'm just going to write it down. All right, so the conditions that you see of the products, it can be of the integral of x to the exponent of n, e to the exponent of ax, whereby we are dealing with algebraic and exponential. And I said on this condition, it is best for you to choose your f of x to be an algebraic, to be x to the exponent of n. Then the rest, it will be the g prime x. It can be a condition of x to the exponent of n times ln of x dx. It can be like that. On that condition, yes, it's best now for us to choose, for you to integrate ln to integrate that is going to be a problem. So on this condition, it's best for you to choose your f of x to be a ln x. All right. It can be of a trig function. It can be x to the exponent of n times a trig function. Maybe it's the sine of ax dx. Maybe it's a cos ax dx. Maybe whatever trig that you can have. Okay. On that condition, it is going to be easier for us if we choose f of x to be a trig function, because if this is not gonna like it's not gonna end, we are going to have a continuous integral. This is to the exponent of n, a continuous integral. So on that part, I'm going to explain actually with question papers. All right, I'm going to explain with question papers, but like I'm saying, it is of best nature that we make our f of x to be a trig function, right? To be a trig function, or we can even make our f of x to be an algebraic, all right? We can make our f of x to be an algebraic. We can make our f of x to be a trigonometric function when it is like that, all right? So here, gonna just take x to the exponent of n, or trig, or the trig, all right? Then, when given e, because it can be an exponential, e to the exponent of ax, and a trig function, maybe it's sine, it's cos, whatever that you're given. When you are given this, it is here, you can take any again. So your f of x can be an exponential, or your f of x can be a trig. You can choose whatever that you want on a condition like that. And we have integration. Again, we're going to apply this on integration of inverse trig, the inverse trig functions. Inverse trig functions, they also need us to apply or to use by parts. And I think, let me just have an example on that one, because it's one of the most confused questions. Let's say you are given to integrate arcsin bx. This is one of the question papers I saw. Yeah, they had a question like this. So let us talk about this question. This is an inverse trig. We are given to the exponent of what? Arcsin. This is arc to the exponent of a negative. It's an inverse function. So when dealing with an inverse function, this is what you do. Just like what we saw in N5, we were told to integrate ln x with respect to x. And what did we do? We said this can be written as the product of 1 times ln x with respect to x, so that this becomes our f of x, and the remaining part is our g prime dx. This is the same scenario or same situation, because we can differentiate this one, we can differentiate it. It's possible, it's easier for us. But to integrate, it's difficult. So we are going to write it as the integral of 1 times arcsin bx with respect to x. So what does it mean? It means that since we can be able to differentiate this, we are going to choose it to be our f of x. Remember, guys, our formula states that the integral of f of x times g prime x dx is equal to f of x by gx minus the integral of f prime x gx dx. This is your formula. You're supposed to know this by heart. Yes, you're given in the formula sheet, but you're supposed to know this. Okay, anyways, this is what I'm saying. We can differentiate this. Remember, f of x is the part that you're supposed to differentiate. So I'm just going to let this to be my f of x, right? So let me just write aside here. So let my f of x be equal to arcsin bx. So what does it mean? It means the rest, if this is my f of x, the remaining is g prime dx. And if this is my f of x, it means the remaining, what is remaining? It's 1 dx. Take note, 1 dx. This is the part that is remaining. So that is going to be your g prime. All right, this is the remaining part, g prime dx. So we've got g prime x dx, which is the remaining part, 1 dx. So that will be 1 dx. So we integrate both sides. With respect to x, this will give us gx, and this will give us the integral of 1 with respect to x is x, right? So here I just wanted us to do it direct, but here I left it because we need to explain this. Okay, here remember, what are we supposed to obtain from f of x? We are supposed to obtain f prime x, which is the derivative of f of x. So I want us to go back again to our formula sheet, right? So that we explain some other things, seeing where are they coming from. It can be of easier. We need arcsin. It's supposed to be on the other page, this page here. All right, here, supposed to be on this page. Okay, here we are. So on the derivatives, like I said, it's easier for us to work with arcsin because we have got the derivative here. It's stated, all right? This is our f of x. This is the derivative of f of x. So the derivative of arcsin f of x is the derivative of f of x. This is f prime. So it's the derivative. All right, let me try and increase this. All right, so this is it. Whenever you differentiate arcsin f of x, you're going to have the first derivative of this f of x over the square root of 1 minus f of x squared. So this is for arcsin f of x. So let us take our formula into consideration. All right. I'm just going to do this. Sorry for that. So that we can go back here. I just hope you're going to understand me here. So this is it. So we said, if whenever you are integrating arcsin x, f of x, right? If this is f of x, this will be, or with respect to x, so this will be f prime x over the square root of 1 minus f of x squared. All right. So taking into consideration here, this is what you're going to do. This is what you're going to have. I mean, we need the first derivative of our f of x. And you said our f of x here is arcsin bx. So this is our f of x. So we need the first derivative, which is the derivative of bx, that is b over the square root of 1 minus f of x squared. So our f of x, we said it's bx. So it is supposed to be bx squared. So it is supposed to be like this, bx squared, of which we know that from our exponents, this can be given as if there is a square that is affecting everything, we raise everything to that exponent. So this is 1 minus b squared x squared. So everything can be raised to the exponent of 2. So that's b squared x squared. Or you can just leave it like this. We do not know what's going to happen later on. Okay, so let's see what we have at this stage. So we just made our calculations aside. So these were the calculations that are necessary. So let us bring back our calculations into the formula. All right. So the question is that we are supposed to integrate this arcsin bx. And I said from our formula of the integral by parts, it states that. All right. So I'm just going to make it this side, guys. Sorry for that. The integral of arcsin bx with respect to x is going to be equal to, okay, so we need f of x by gx on our formula, f of x times gx, whereby we said f of x is arcsin bx and gx is x. So it's arcsin bx, which is f of x, gx is x. So we're going to multiply these two, arcsin bx times x, okay, minus the integral of, so what do we have here? The integral of f prime x, which is the first derivative of f of x. And this is f prime x, the one that we got here. Okay, so we got b over the square root of 1 minus b squared x squared times gx. All right, and what is our gx? Our gx is x. So we got x here. All right, and everything must be integrated with respect to x. All right, so this is it. You did your by parts concept, like to find your requirements of the formula, what is needed on the formula. After that, substitute on the formula. This is it here. We've substituted into the formula. So this we can simplify further. How can we simplify this further? That is the question. All right. So if we had to check properly here, it's just a product. So it's arcsin bx times x. This will be x arcsin bx. All right. Minus, remember b is a constant. X is the variable. So wherever it's like 2x, it's like arcsin 2x or arcsin 7x. B is a constant. So if it is a constant, therefore we can use whatever that we're doing before when there is a constant. What is it that we're doing? We can take the constant out of the integral, which is fine. Or we can leave it like that. All right, let's write this. This is same as over 1. So you're going to multiply b times x, which is going to be bx over the square root of 1 minus b squared x squared. So this is b squared x squared. So like I said, you can just write as bx squared and combine it like that, all right, with respect to x. So this is it, we just multiplied, combined, and everything. So it's supposed to integrate this. So the question is, how are we going to integrate this? Because we are supposed to integrate. So how are we going to integrate this part? That is the question. Okay. This one is no longer by parts. It's now you and your own understanding of your integrals. You think of, is there a formula that I can use here? No. Let's think of substitution, because there is a bx here. There is a bx squared, b squared x. There's something that is fishy there. Let's think of substitution method. All right. So how can we integrate now? It's up to us. And like I said, let us think of what? Substitution method. All right. So thinking along these lines of our substitution method, all right? So let me just work here using substitution method. Substitution method. All right. This is what you're going to have here. Let us just choose this to be our u. It's going to be easier that way. Remember your substitution method, because we want something that is going to cancel with bx, and we have some strong feeling that the b and the b there will cancel. Remember, b is a constant. So x there will cancel somehow. Okay, let's do that. Let's see. Let our u to be equal to 1 minus b squared x squared. Remember, substitution method, guys. So you're going to have the derivative of u with respect to x from our n5. Okay, the derivative of 1, that's a 0. Remember, b is a constant. Wherever we see b, we see a constant. So it's like this. If it was the integral, the derivative of 1 minus 3x squared, what do? You take this constant, you differentiate x squared. So it will be minus 3 times 2x. So that is the condition that you are simply having there. All right. So there we have got a constant. So you have to take that constant as it is, because it's multiplied to x. It's different from this single constant. So it's minus b squared times the derivative of x, because x is our variable and we are differentiating with respect to x. So this will be 2x. So meaning to say we're going to get minus 2b squared x. So this is the derivative of u with respect to x. You play around with your change of subject, make dx the subject, you cross multiply this and that, guys. Remember that concept. So this is going to cross multiply. This will be du is equal to minus 2b squared x times dx. We want to remove this dx. So you're going to make dx the subject. So we divide by negative 2b squared x by negative 2b squared x. So this is it, guys. That's our dx, which is minus du. The minus, just take it on top, over 2b squared x, okay, or 2b squared x. Substitution method, guys, just go back to N5 and just have a recap, okay, because this is a continuation, remember that. Okay, so now that you have dx, this is our dx, and this is the major part that we want to get rid here. So this is going to be given as x times arcsin of bx minus the integral of, this is just going to remain as it is, bx over the square root of 1 minus b squared x squared is our u. Remember, we said let u be equal to 1 minus b squared x squared. So this is the square root of u times dx, and our dx, this is what we got from our dx. We got minus du. So I'm just going to do this stage by stage. I know I'm not supposed to do like this, but I'm just going to do it stage by stage so that we all understand this question. All right. So this is what we do. We're supposed to substitute dx as usual, guys. You'll find your, I don't know how you're going to do this, because there are so many ways there on your substitution method. How you're going to work it, there are so many ways, but this is what I taught you in N5. So I'm just going to continue that so that I don't bring confusion to you guys. So remember, you're supposed to integrate with respect to u now, because we've substituted with respect to u. We no longer have with respect to x. So what's going to happen here? Let's simplify the x, and the x is going to cancel. So this is b into b, that's 1. B into b squared, you're going to remain with b. Remember, I said b is a constant. So we can take it out of the integral, just like the previous case that we had. So this will be x arcsin of bx minus So we have got a negative also here, and this negative, so negative, negative, it is going to give us a positive. So that will be a positive, okay? Take out of the integral, remember there is, on top we took the negative, and the negative gave us a positive. So you're gonna remain with 1 over 2b. Remember this is a constant. So we take that out of the integral. So it's 1 over 2b like this. The integral of 1 over the square root of u. So this is what is remaining inside of our integral. 2b, it's a constant. It's just like a 4, just like 1 over 5, just like 1 over 7. You take it out of the integral. So this is the one that you're supposed to integrate. So what are we supposed to do now? Okay, this one can be integrated. Remember, it's with respect to u. So this is just going to be direct x, arcsin of bx plus 1 over 2b. Remember, the 1 over the square root of u means u to the exponent of negative half. U to the exponent of a half is the square root. But to remove the 1 over, you introduce a negative. So this is what we are supposed to integrate with respect to u. So remember the integrals, guys. We add the exponent, okay, and divide by the new exponent. So if we add 1 on the exponent, what do we get? This is minus half. So minus 1 over 2. We add 1 on the exponent, that will be 1 over 2. So that's u to the exponent of 1 over 2 over 1 over 2. We are now integrating. So it's 1 divided by 1 over 2, something like that, okay? 1 divided by the answer that we had, so it will be 2. So you're going to have this as 2u to the exponent of a half, okay? So this is what we have. After integrating this, we're going to get 2u to the exponent of a half, of which we said let u be equal to what? 1 minus b squared x squared. 1 minus b squared x squared. So that means this is simply 2 into our u, which is 1 minus b squared x squared, but it is raised to the exponent of a half. Okay, so this is what we are going to bring here. So after multiplying here, we're gonna get, after integrating this, I mean, this is what we got. We say this is same as u to the exponent of minus half. We integrate, we get this answer. So this is gonna be 2 into 1 minus b squared x squared to the exponent of a half. So this is what we are obtaining from integrating the square root of what? The square 1 over the square root of u. So that is, we are done because we do not have any integral. So we're just going to write the constant of integration. But as you can see here, there's something that can be canceled. This one and this one can cancel 2 and 2. So we are done. Yeah, here we are done, guys. So that will be x times arcsin of bx. Then this will be plus. If we take this, we're going to just write it as 1 over b. Right? So this is 1 over b times the square root of this, 1 over b, and to the exponent of half means the square root of. So this is the square root of 1 minus b squared x squared, of which I said this can be written as this b squared x squared, or you can write as bx squared. It's one and the same thing, okay? Then we add the constant of integration at the end. We are done. All right, so exactly as this. So it's actually an interesting, a very, very interesting part to have this, okay? As you can see, that is how you integrate an inverse trig. So it can be an inverse of cos, can be an inverse of sine, whatever inverse that you're given, some certain inverse functions can be integrated by parts. This is what you just need to do. So like I said, from the first part, this is what we had. We had to use our by parts method, all right? But if, like I said, if it's an inverse, you have to add 1 on your question. So it's going to be 1 times, so that 1 becomes your f of, 1 becomes your g prime x, so that it can be integrated to give us x. But our f of x is arcsin because we can differentiate this. We differentiate our arcsin, all right? We find the integral of 1, we get x. Whatever that we have here, we just have to bring it back to the formula, our formula. Remember our by parts formula. We just have to substitute into the formula. This is what we did here. when you have substituted, whatever comes here, it's up to you. Whatever that's going to happen here, it's up to you. It's either you're going to have a substitution method on that integral. It's either you are going back to by parts method again. You're going to use that by parts method again. Maybe it's just a straightforward integral. You just integrate. So I don't know. It depends with what you're given. But as for this, we had to use substitution method so that we get rid of this px. So that's why we had to use our substitution method. But if there's any other method that you see that we could have used here, let me know, guys, on the comment section so that we can be able to also work with that method for the benefit of others in the next class. All right, but that was it. Then now simplify your integrals, this and that, your basic integrals. Like I said, your N5 is still supposed to be applied or to be used. All right, so that's it. Let's see another question. We talked about the integral of an exponential function and a trig function. Okay, let's see this. The integral of e to the exponent of minus x times the cosine of x with respect to x. All right, so like I said, on this one, it's up to you. You choose whatever that you want. You can choose exponential to be f of x or cos to be f of x, a trig function. I talked about this. So it's up to you on this one. So here, I'm just going to choose f of x. All right. So on this part, I'm just going to let my f of x to be equal e to the exponent of minus f of minus x. So remember the derivative of e, you differentiate your f of x, all right? You differentiate your f of x, your function for x, which is -1, all right? Which is -1, then you multiply by e to the exponent of as it is. So this is simply minus e to the exponent of minus x. So what I'm simply saying is that the derivative with respect to x of e to the exponent of f of x is the first derivative of f of x times e to the exponent of f of x from this one. Okay, so this is how you simply play around with e on the derivative. We talked about e on the integrals, but it can also be differentiated. All right, then by doing this, it means that the remaining part is going to be of g prime. All right, remember your formula, guys. Do not forget your formula. Remember, we talked about this, the integral of f of x g prime x dx is equal to f of x by gx minus the integral of f prime gx dx. So meaning to say, we are going to remain with the g prime x. So that is the one that we need here, right? So g prime x dx, which is the remaining part. If we took this, we're going to remain with this. So that is cos x dx. Integrate both sides to obtain gx. So that's gx is going to be the integral of cos. Remember, if you differentiate a sign, it gives you a cos. The integral of a cos, it's a sine. So this one is sine x. Yes, we're supposed to have sine x plus c, but we are not done with integral. So don't bother yourself writing the c. So this is it. We have everything, guys, that we need. Let us substitute into the formula. So this whole integral that we have, it is going to give us f of x by gx, whereby our f of x, it's e to the exponent of minus x times gx, which is the sine of x, minus the integral of f prime x. F prime x here, we got negative e to the exponent of minus x. So times gx dx, and this is our gx, which is going to be sine x. So this is sine x dx like this. Okay. So I want you to see here, guys, here, I want you to be very, 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 very careful. Whether you chose your f of x to be cos, okay? Maybe you chose this to be your f of x. Whether you are going to have like a situation of the same, you're going to have a same situation, not like exactly the same, but the answers are going to be the same. The situation and scenario is also the same. So this is what you're going to have. E to the exponent of minus x times the sine of x, negative, negative, take that negative out of the integral, it becomes a positive, negative, negative, so that will be positive. So we are left with a positive. Since we have taken out this out of the integral, we are left with the integral of e to the exponent of minus x, the sine of x times dx, like this. Okay. I want you to properly see and analyze your question. It's not the first time that we have this. We saw this on the integral of, it was something like x squared times, maybe it's a e or whatever that we have. So we see that e is always having a problem whenever e is meeting with something, because here we see that we have to integrate, but what is happening? We have to integrate again by parts because it's a product. Again, we are back to the product of two terms. So we are back again, guys, by parts here. We have to use by parts again. So this is what's going to happen. Let us use our by parts. I want you to see what's going to happen. So remember, what we want to use here is this one. We're going to use by parts here again. So that's the integral of e to the exponent of minus x. Okay, let me just even write it here. Let me just write it aside here. So we need the integral of e to the exponent of minus x sine x. Remember, that was sine x. This one. So it's going to be like previous case. You find that integral, then you bring it back to the question. Okay, you substitute it back to the question. So I want you to see what's going to happen here. Just like the previous case, we are going to let your f of x, just like what we got, f of x be equal to this. So f of x is just going to be e. What you choose in the first place, you have to choose it again. If you choose in the first place to say, let f of x be a trig function, use also that on the second integral by parts. All right, so this is what I'm trying to say. Since we used this, which means our f of x is just going to remain as it is. Our f of x is be 3 e to the exponent of minus x. And so guys, the derivative of f of x, we found this before. We go toward minus e to the exponent of minus x, all right? And the remaining part, it's for g prime. So gonna have g prime x dx, which is what is remaining here, which is sine x. So there we are remaining with sine x dx. So we integrate both sides so that we obtain gx, all right? So we're gonna obtain gx in that manner. So what is the integral of sine? Sine gives us a negative cos. If you integrate, you can also check your formula sheet. So this is negative cos x. All right. So we're going to substitute into the formula now. So this is it. This whole integral here is going to give us, all right. Remember our formula is f of x by gx. Right here, our formula, f of x by gx. This is our by parts formula. Let me increase a little bit. All right, like this. So our by parts formula states we're going to have f of x by gx, which is f of x e to the exponent of minus x by gx, which is minus cos of x, like this, minus the integral of f prime x, which is f prime, it's minus e to the exponent of minus x times gx dx, which is our gx dx, which is minus cos of x dx, like this. Okay. So inside of the integral, it's negative, which is going to give us what? A positive. So meaning to say this will be, right here, there's a negative on cos, so it will be minus e to the exponent of minus x cos of x, like this. The minus is not going to change because already here we've got a positive. Remember I said negative here. It gave us what? A positive. So already we have a positive. So this is not going to change. The minus is just going to remain as it is. But we're going to have the integral of e to the exponent of minus x cos of x dx. So guys, we were supposed to integrate this here. But I want you to see here, e to the exponent of minus x cos x dx, because it's a product again, we're supposed to use by parts again. But I want you to see this, e to the exponent of minus x cos x, this is it here, e to the exponent of minus x cos x dx. So we are going to have a repetition again, another. So what do? Okay, you bring this solution. I want you to see how do you combine this. You're going to take this solution. All right, remember, before this was the integral of what? E to the exponent of minus x cos x, the one that we integrated up to this stage. All right, this is what you're going to do. So you're going to take our question as it was before. Okay, this is our question. The integral of e to the exponent of minus x cos of x dx is equal to, right? This is what we got when we integrated. We got this statement here, which is e to the exponent of minus x, the sine of x, plus the integral of this part here. This is the one that we are supposed to integrate, e to the exponent of minus x sine x. And when we integrated this, e to the exponent of minus x sine x, which is this one, we integrated, and this is what we got. So this is the solution that we have. So we are going to take our solution as it is minus e to the exponent of minus x as it is. So let us just open a bracket here. Remember, we are writing here on this integral plus this integral. So the integral of this is the answer that I'm writing here, right? So this is the answer, minus e to the exponent of minus x, the cosine of x, minus the integral of, remember here we ended up with the integral of e to the exponent of minus x, the cosine of x dx. This is what we ended up with. And we said we were supposed to use by parts method again, but we realized that this thing, we have it here. We worked it before. So instead of applying by parts, combine, and this is what you're going to see. You see that there are two expressions that are, or the terms that are the same. This integral and this integral are the same. So you have to take them to one side, integral, combine them. But before that, we have to just get rid of this sign, combine it to be a single integral. So this is the integral of e to the exponent of minus x. The cosine of x with respect to x is equal to e to the exponent of minus x, the sine of x. The sine of x here plus and a minus, that's a minus. So it will be minus e to the exponent of minus x, the cosine of x, plus again, and a minus, it will be a minus. So that will be the minus the integral of e to the exponent of minus x, cosine of x with respect to x. And this part, like I said, and this part are the same. So we're going to take it to one side of the integral. If we take it this side, it's a minus. So if we take it this side, it's going to be a plus. So it's just like there is x plus, there is x here. X is equal to 3 minus x. And you take x this side, what's going to happen? It will be x plus x, which is 1 plus 1, which is 1 plus 1 is 2. So it will be 2x. So the moment I take this integral this side, because they are the same integrals, and it's now a positive. So it is going to give us 2, the integral of e to the exponent of minus x, cos of x dx, which is equal to, remember we transposed this. This is what we transposed to the left-hand side. So that's why we added and got a 2, because they are the same. So we are going to remain with this on the right-hand side. We are going to remain with e to the exponent of minus x, sine of x, minus e to the exponent of minus x, the cosine of x. So as you can see, the 2, we do not want this. The question was for us to integrate. This is our question. E to the exponent of minus x cos x with respect to x. And this is what we see here. This is what we have. What is just affecting is these 2. So how do I get rid of these 2? I just have to divide by 2. And the moment I divide by 2, it's simply divide by 2 here. So here I'm just going to divide everything by what? By 2. So that means this will cancel. I remain with the integral of e to the exponent of minus x times cos of x with respect to x, which is equal to this. 1 over 2 can be just be written as 1 over 2 into e to the exponent of minus x, the sine of x, like this, minus e to the exponent of minus x, the cosine of x, like this, plus constant of integration. So we can just leave it at that stage. Since we are done integrating, that's why we have to introduce the c, the cost of integration, or you can expand the brackets with a half. All right, multiply by a half throughout, it's done. So this is how by parts can be done. This is how we can use by parts. So if you check properly here, in the first stage, it was just a normal integral. We applied our normal by parts. Then we integrate. The moment that we are now to integrate again, we say this thing has to be integrated again and by parts. We do that. We apply our by parts, we're done. But on the application of that by parts again, we see a stage that we are supposed to use by parts. On a normal sense, in some cases, like the first case that we saw, we had to use by parts again. We had to apply it twice, if you still remember that question. But on this one, it's impossible, because what we are supposed to integrate again by parts is exactly what you have on your question. So you just have to substitute whatever that you got as it is, right? This is it here. On this integral, so we have to substitute as it is, the first part, plus what we got from this integral. This integral gave us this expression. We just substitute as it is, this whole part of our integral that we got from this e to the exponent of minus x sine x. You substitute that, all right? After substituting, you integrate. After substituting, you see that they are the same. So instead of you integrating this part and this part that are the same, you take them to one side of the integral, because that is exactly what your question is asking. It's asking you to integrate e to the exponent of minus x cos x. So you don't have to integrate it again. You just have to combine. By combining, you are done with your integral, and you make that to be the subject of the formula. That percent, you make it to be the subject of the formula. So like I said, integration is something that is very, very important by parts. All right, let's consider this, the last question. Let us just have last question, guys, very, very easy, and let us save it. The integral of 5x e to the exponent of minus 2x with respect to x. Remember, we saw the the 5x to the exponent of 2. This is just direct. And I said, whenever you're dealing with an algebraic and a trig, it's best for you to make the algebraic to be your f of x, all right? So it's f of x g prime x dx is equal to f of x by gx minus the integral of f prime gx dx. Okay, let's do this and just finalize our introduction. All right, so that's it. Let our f of x to be the algebraic, which is 5x, this case, all right? So if we let this to be 5x, we're gonna need the first derivative of that 5x, which is 5. And what is remaining in this case is g prime x, okay? G prime x dx. So that means our g prime x dx is the remaining part, which is e to the exponent of negative 2x dx. We integrate this both sides, we get our gx. So remember, I talked about the integral of e. We said is the e to the exponent of f of x as it is over the first derivative of f of x, which is minus 2. So this is same as e to the x minus e to the exponent of minus 2x over 2. Okay, so we've got our gx. We've got everything actually here. So just if gonna apply our formula. So this is equal to f of x by gx, right? So this whole integral is gonna be equal to f of x by gx, whereby f of x is 5x. So we're gonna have 5x times gx. And this is what we got from gx. We got negative, all right, let's just multiply as it is, negative e to the exponent of minus 2x over 2 minus the integral of f prime gx, right? So f prime x, which is 5. So this will be 5 times gx dx. And this is our gx dx. We got negative e to the exponent of minus 2x over 2 with respect to x. All right, so that's it. This one, like I said, is just an easy question. If you have to check properly, there's no need for us to even apply by parts again. It's just a normal simplification. So 5 times 1 over minus 1 over 2. This is same as minus 1 over 2 on e here. There is a negative e, so it's negative 1 over e. Negative 1 over 2, so it's just going to multiply 5 times minus 1 over 2, which is minus 5 over 2x times e to the exponent of minus 2x, all right? Then here, we're going to take negative, that will be a positive. Remember, this is minus, all right? So that will be negative, negative, which is a positive. So you're going to have positive 5 over 2. So you're going to take the 5 over 2 out of the integral. We remain with the integral of negative 2x with respect to x. So this we integrated before. Remember, we integrated e to the exponent of minus 2x here. That's the advantage of working with e, because another part you just repeat as it is, all right? So this will be minus 5 over 2 x e to the exponent of minus 2x plus 5 over 2 times the integral of e to the exponent of x, which gave us this, minus e to the exponent of minus 2x, everything over 2. Remember, this is what we got. All right, since there's nothing to be integrated again, we can introduce our constant of what? Our constant of integration. All right, so let us just simplify and see what you're going to have at the end. So therefore, this whole integral that we had is going to give us minus 5 over 2 x e to the exponent of minus 2x. Then we multiply, this is same as minus half. So it's 5 over 2 times minus half. If we multiply this, we are going to get minus 5 over 4. So this is minus 5 over 4 e to the exponent of minus 2x plus the constant of integration. All right, nothing further to be done. You'll be done with your integral. In this case, there's nothing that you're going to do. So it was a straightforward application that we see. Just introduce your f of x and so forth, integrate what need to be integrated, what need to be differentiated from your f of x, then substitute into the formula. So as you can see, the whole part here is just for us to do our recap from our N5. It's a continuation. The only thing that we noticed in our continuation is that we can now integrate 2 times or 3 times in the same integral. We are just integrating more than once, okay? Or sometimes what we integrated, instead of it to be integrated again, we have to combine with the question to formulate or to make that to be the subject of the formula, which is our question. So guys, that's it. We just have to revise as many questions. And also we saw that this can also be used in the integral of inverse trigonometric functions. So we just have to work with inverse functions, some certain inverse functions in this integral. So let me know, guys, on the comment section, the question papers that we can now work with so that we can have this into full understanding, where there's a question that we have that needs to be applied by parts, but still having a challenge. That's it. Let me know about that question.